All right, and I think we are about ready to start our session today for AI Summer, but we will give folks just a minute or two to keep just trickling on in. All right, and if the repo isn't looking familiar, I'm just going to go ahead and just drop that on in the chat so that everyone can access it. We'll be using it today. I'm just keeping an eye on the participants list here, just making sure. We'll start whenever we slow down a bit. I see we have some more people coming in. But again, welcome to AI Summer. As you know, we've been doing this for a little while since May 5th. And so we're excited that you're joining us back again today. And again, we'll just give people maybe a minute or two to continue coming in so we can talk more about AI.
And today, in broad outlines, we're going to be starting talking about agents and how to actually put these together, LangFlow. Then we're going to be getting some more hands-on experience with an advanced, lighter AI agent called O3. Then we're going to be talking about multimodal models, how they work, where they come from, and the differences between them. And we'll be ending up today with some interactive work with exploring the new capabilities of multimodal with native multimodal models. Professor Bell is going to be teaching the first part, and then I'll be popping back on and handling the latter part. But glad you all are here, and look forward to spending some time with you later on after Professor Bell is all finished up.
Awesome, awesome. Thank you very much. Well, I think with that, I think it's a great time to go ahead and, really jump into the work for today. So again, we just put, the links into the chat for the repo, and we're going to be really using that today. But again, welcome back to AI Summer. We're on week 2, it's the second day. And we're glad to have you back. Today, as Jesse was saying, we're going to talk a little bit more about what you learned about on Monday. So on Monday, we talked a lot about LLMs, how they work, their innards, and how these relate in particular to reasoning models. Today, we're going to see how we can apply those into our own system if that's something that we choose to develop. Um, and again, I'm not sure if I've introduced myself in this set of weeks, but I'm Sharo Bell. I'm the director of the data science minor here at Vanderbilt, and I'm also a senior data scientist at the DSI. It is exciting to be here. We're talking about some of my favorite topics. And so today we're going to be building things again to reflect some of the conceptual learning that we've had. So also, just so we all know, I think we're familiar with this, but I am joined by who you just were talking to, Dr. Spencer Smith. Also, my colleague Umang Chaudhry is here. So if you have questions, make sure to reach out to him. And also our postdoc, Abby Petulante, is here. And so if you have questions, you can also feel free to reach out to her. Always drop any questions that you have in the chat. You can also feel free to unmute. And I think that's the beginning spiel for today. Are there any questions before we really get started? All right. So, as Jesse said, today we're getting, resending the link to the repo. No problem. And then this is the repo. Just a reminder that the links will be posted here. The things you need to know, want to catch up on, see any of the breakout room documents, they will be here. So you see the information from last week if you want to catch up on Replit, Cursor, any of that great stuff, what it's like to do AI-assisted coding. And then here we have this week's material. So today, again, we are talking about building our own AI systems based on the information that we learned from Jesse on Monday. And so we are going to delve deeper into this. and really take a look at what it's like to implement this on your own. As we've talked about in the first week, we talked about a platform called Replit. We've talked about Cursor. We've talked about Windsurf. You have experienced on Monday what it was like to use Perplexity. All of these systems are using the AI models that we're talking about. So we've seen the O3 models, we've seen GPT-4o. All of these platforms, though, are using those LLM or OpenAI Anthropic systems to implement something else. And so that's really what we're focusing on today. What happens and how do we do it when we see these models that we really like, but we want to customize them or use them in a particular way that maybe is not out there or is really particular to our own application. So maybe you've had enough of perplexity and you think it's too straightforward and you want to make something called like complexity. And it's the hardest thing that's ever been used and it doesn't make any sense and it confuses everybody. Perfect. You can also learn how to do that today. So, why? So, again, if you want to make your own system, if you need it to be unique to your own data or your own computer, very specifically, if you want your AI system to be specific to the data, maybe for your company, if you want to customize its underlying behavior, these are all reasons that you might choose to create your own AI-based systems instead of hopping onto something like ChatGPT or like Claude or some like a platform that's already been created for you. So, how are we going to do that? Well, we are combining information from the last 2 weeks, and we're going to put it all together. And we're going to add one more little piece. So just so you don't get lost, we have a document up here. It says week two, day two, and you can just click on that. A nice rendering of what we're going to go through in order to make your accounts. And also, just in case you like kind of maybe the system doesn't go as fast as you'd like. So the platform that we're going to use today is called LangFlow. We will go to this site if you want to. You can just go ahead and click in it and get started. You will need to create an account. But well, I guess I can just click it too. So I'm just going to command or control click. So I'm opening up this other tab. So here we are on LangFlow, right? And when you look at it, it has that Lang little bit in it. Anytime you're talking about these large language models, like so many platforms start with Lang, it's probably going to have to do with some LLM stuff. But then it's talking about this flow, sort of like information flows from one piece of another, one piece of a system to another. Even in looking at their just front image, you see like this set of words that seems to be connected into some system that is talking about GPT-4o mini. You need something that's called an API key, which we talked about in the last week. And then we're also doing some sort of precise, creative, like what is that? So this is what LangFlow is for. We can always think about systems being as something that we can program, but maybe we want to understand the overall system and we don't really want to program to begin with. LangFlow is something that can help us do this. So what you're going to do, if you don't already have an account, you can just go ahead and get started for free and click that button. And then you can choose whatever method here that you would like to go with. And so I'm just going to give you a few moments to keep clicking through whatever you need to do to sign up for LangFlow. It also is associated with DataStax, so maybe you already might have an account with them. But I'm just going to give you a few moments to click through that. And in the meantime, actually, I am just going to go ahead and sign in. I'm going to use this, but again, you will probably need to fill out these things or sign up with GitHub or Google. Oh, and actually, I'm already signed in, so just kidding. And so you're probably going to eventually see something like this. If this is not immediately what you see, you might see a darker color screen with something that says like create new flow or something like that. If you see anything that says new flow, you are perfectly there. Otherwise, if you run into any issue, just feel free to jot that in the chat or unmute, but I'll give you all a second to keep working on that. I've lost a little mouse there. There we go. All right. And if you visit your reactions, actually, is it that? It's been so long. Yes, your reactions. If you're able and your account has already been created and you're seeing like the right kind of screen right here, um, the site is LangFlow. And so the way that we can get to that, just popping back, if we start at the repo and we go down to week 2, day 2, we can visit langflowhere.org. And I love that you're thinking about LangChain. Umang will have some great information for you about LangChain. You will learn so much. Today is LangFlow. Good question. There's many Langs. There'll be a Lang fuse. There's a Lang trace. There's Lang Smith. Are they all associated? Maybe not. There's a Lang graph. There's many Langs. Sometimes they're associated, sometimes they're not. But this one today is going to be Lang flow because we're going to look at the information flow from one component to another. All right, so let's visit our reactions and actually have to find my own reactions at this point. Well, um, hmm, we might just have to just keep moving forward. Is anyone having any challenges here, or we're pretty set with creating our user account on LangFlow? And go ahead and just put a thumbs up there. Yeah, there we go. Go ahead and just throw up a thumbs up if you're able to do that. And if you are all set, great, things are looking good. Okay. All right, great. If there's any questions that you have, this is very hands-on, so try to do it with me. And I think that's how you'll have the greatest benefit. But if you have any questions, again, Umang and Abby are here to help. So feel free to drop any questions in the chat or just reach out to them. Okay, so now that we're here and we're able to click something that looks like new flow, yes. So if you get to Astra Data Stacks, if you see anything up here that looks like this, you can go like back and forth. And you're going to try really hard to go to this LangFlow one. And if all fails and it tries to fight you some more, you can always go back to langflow.com and then go to the bottom and just click sign in. And then it should bring you to the right screen. Okay. So now we're just going to go to new flow. So we're not going to make this overly complicated, but we are going to explore many of the templates. So something to understand about kind of the state of AI and AI systems is that there are so many templates and so many systems that have already, like their outline and their general functionality has already been created. And so to a good bit of extent, there is a lot of the work that you do revolves more around customization and understanding your use case to understand how it is that you will use generative AI to solve the problem that you're after. And so a lot of the structure is already there. The question is, how do you need to change that structure to meet the objectives that you have? So even in looking at like a page that looks like this, something that I would recommend doing after the class ends, as you were navigating your life on Thursday, if you have some more time, is to go through some of these use cases and also just go through the methodology. So here, what we're going to do is we're just going to start with basic prompting. You do see something here that says vector store RAG. Umang will talk to you a lot more about what RAG is and how it works. And then in the last week, we'll talk more about agents. And we've already talked about them a little bit, but we'll talk about them more. But here, we're just going to start with basic prompting. This is going to be the usage of the LLMs that we talked about on Monday in an AI system. So exciting. Is everyone on this page? Thumbs up. And if you need some help, red X or drop a question in the chat. Good, good, good. Things are looking good. Good, good. Great. Things are looking great. All right. So again, this is the introduction essentially to prompting and how things sort of work together. But again, make sure that you explore these other use cases. They're absolutely incredible. Okay, so what are we looking at here, right? Okay, so in our minds, let's just think about when we go to ChatGPT and we start using it. There's this page that we go to. There's this box at the bottom. We input words into the box, we click enter. Then what we observe is that there are words that are responding to us, right? And so what happens there is what we might expect. We type words into the box and we click enter or click send. That is sent somewhere to some LLM somewhere, and then it forward propagates its query to through the LLM, whatever other software that they have, and then it returns the response to us for us to read. This is how we imagine ChatGPT or a system like that working. In fact, we can see that that is generally how it is working. So, in looking at these boxes and how things flow, again, we might expect that we have that input box, right? The stuff that we're going to write to the LLM. This is called the chat input. And so, this is the input query that is going to go into our system. We also have this other thing, which is interesting. You can read what it says. It says, answer the user as if you were a Gen AI expert, enthusiastic about helping them get started building something fresh. This is interesting, right? That just, what is that? And you see that it's going into something called a system message. What are both of these things connected to? Well, exactly what we might expect. This is OpenAI's LLM GPT-4o Mini. And so you can see that again, this input that we are writing as the user, this is going to go into the input of the LLM as we might expect. There's this other sort of hidden thing that when we think about ChatGPT, we actually don't like see, but there seems to be some sort of instruction about how the system should behave. Interesting. We'll come back to that. And again, we have the actual model that you're going to use. You can imagine that in ChatGPT at the top, we always have that little drop-down menu of what it is that we actually the LLM that we want to use or the model that we want to use, and we're able to check it out. We're able to select the one that we want here. And here we have our little friend, the API key. I'm going to pause just a second and we're going to quiz ourselves. We're going to think back to what Miranda so astutely instructed us about last week. Can someone remind me about the purpose of an API key? And you can either unmute or drop your thoughts in the chat. Security, love it. Other thoughts? Security is a great answer. Provides customized and monitored access to the model with security and logging. Beautiful. This is a great answer. Both are great answers. This is a more full answer. Exactly. So our API keys are what is going to identify the key technically, but us or us, the developer, us, the user, us, the person who's trying to access this is going to identify us to OpenAI so that it knows that we have access to functionality A, B, C, and D, but maybe not functionality C. It also knows that when it wants to, when we start using those resources, that it has access to credit card A, B, C, and D. So then when we have a lot of usage of the system, then it can bill credit cards A, B, C, and D. So this is associating some particular account with billing, with the resources, and also enabling logging. So this looks like something that we're going to need, right? So beyond that, we have our AI, our OpenAI model. And then once those inputs go into our system, it does some sort of computation. We expect that that will come out and we will see that output. And so this is how we would expect a system to run. So we actually have this full thing. I mean, it's already here. Why not just go to this playground? So if we click on the playground, we then are looking at something that's giving ChatGPT, Anthropic, Google, something we're used to looking at. And maybe we just try to interact with the system as normal. So write a haiku about a cat. Oh my goodness. So I just got this error. It looks like you missed something. OpenAI is missing your OpenAI API key. Did anybody else get that? Anybody? Yep. All right. So I'm gonna like make a huge conclusion. Yep, we see some people got it. Shoot, that means we have to go make some API keys. However, we are just gonna not make this particular API key. So we're not gonna make one for OpenAI, but we are gonna make one for another system. So if we want to use another type of AI system instead of OpenAI's, what we can do is just click on it and then just click delete. So we're not going to use OpenAI, but luckily LangFlow provides us lots of integrations that we can use if we want to use a different AI provider. So let's see. Inputs, outputs, we have these different things that we can look at. We're going to go to models. So expanding that models tab, number one, we tend to think about some very specific providers of LLMs and AI systems, but actually there's lots of them. So, I mean, there's a lot of things there that you can pick from. There's a lot of AI functionality out there, something to explore further as well. But what we're going to pick is Google Generative AI. And so we're going to take this model provider and we're going to click and drag, stick it right there, right where OpenAI used to be. So now that we have this AI model in here, and we remember what our connections were before, I'm going to have you real quick try to make these connections between the inputs and the prompts with the output. So take a second and try to connect this up the way that it was connected before so you can have your inputs go into Google Generative AI and then the response from that provider going into the chat output. And while you're working on that, there was a question in the chat. And the question is, just wondering why you decided to delete the OpenAI model rather than provide it with an API key. Um, the way that's phrased, I'm so tickled. Like I'm having to hold in this laugh. I just think it's very funny phrasing. But the reason is because with OpenAI, you usually have to put in a credit card. And so some people don't have credit cards. And so we're going to use a provider instead that doesn't require you to put in a credit card like upfront. Ooh, and someone says, how can we know our API key? How can we find it? I love that question. Does anyone want to quickly share? I don't know if we can screenshot, if we can screenshot things and put them in the chat, but does anyone want to share how they've connected or tell me how to connect back up the system? I'm guessing this message goes to input. You can let me know if you disagree. This prompt message is going to go into the system message, which we will come back to. This message thing here is going to come back to our output. So now we're all connected back up. But we know when we run this, we're going to be back in the OpenAI moment where it was like, you don't have an API key. Who are you? Like, what do you want from me? So now we're going to try to create this API key. So let's do that. So one thing that we can do is go back to our instructions and we can go to aistudio.google.com. So I'm going to command or control click that. What is that? I'm going to close that. And we would get here. This whole page is just interesting just to know. So explore this later. But we're going to go to Google AI Studio. Again, there's a lot interesting also just foundationally about this page. When you look at it, you see like something that is, again, giving this chatty sort of interface that you're used to using. But in the sidebar, you see something that you're not used to seeing, which is this, well, A token count, but the ability to control the temperature, the ability to look at different kinds of tools that are there for the system to use and whether you want to activate them or not, how you want to edit your safety sequence. I mean, there's a lot here that you're not used to seeing, but these are LLM-y things. And so definitely take a look at that. But before I get too far gone with that, we're going to go and create our API key. So we're going to click on this. I have an infinity of these. And so what you're going to do is you're going to click this blue Create API key. It might ask you to create it somewhere in particular. And so you can just pick the Gemini API if that's the one that pops up. I think that might be like something closer to a default. And then you can create that API key. It might also have you create a project first and then make you create that API key in it. We're going to click this one. And here we go. So this is a very funny moment whenever you're like doing these sorts of things and it's like recorded because there goes the API key, right? And so recorded. So essentially I can always invalidate these and just like throw them in the garbage. So even though you're seeing them, they wouldn't be of any use. But here you see your API key. It looks long and complicated. And that is to, again, identify you uniquely for the resources that you're able to use. And so the system can authenticate you. And so this API key is between us, the user, me, the signed in user here, and Gemini, specifically the Gemini API, or maybe Google AI Studio as a whole, but I'm not sure. But specifically for sure, the Gemini API. Okay. So if I were to go and try to use this same API key on OpenAI, they'd be like, what are you talking about? Like, we don't know what that is. And that is because this API key is between me and Google. I would go on OpenAI's platform and create a different API key with them because it's a different platform. The same way I have a specific account on Google, when I go to OpenAI, I have a specific account with OpenAI. So now we're just going to copy this, read the words. So it also says, like, don't just be posting this online, don't make it public. And again, usually that's because it's associated with like your billing and someone gets a hold of it, especially ones that are high value. Like I think the O3 models are like $60 or something for input or output, one of the two. That can run up a pretty serious charge really quick. And so if someone has your API key, they'll just bill you for all of that. Okay, so we copied that. Oh, so someone says that it says failed to create API key, permission denied. You may need to sign. So check on what you're perfect. Thank you, Mom. That's a perfect answer. And the answer is to switch to look at the account you're signed in with and switch to a personal one. And so okay, so now that we have our API key copied, what we're gonna do is we're just gonna paste that in there. We could look at it if we wanted to, just to make sure. Sometimes you should do that because sometimes you paste it in. Hmm. Sometimes you paste it in and it's not what you expected. It's the paragraph that you accidentally copied right after you copied the API key. So it should be an assortment of letters and numbers. And then the person who's asking about the permission denied, maybe you sign out and sign back in. Delete cookies in your web address or in your browser. It could help, but I'm not sure. So now that we have this API key ready, we do see something, which is that we have different options than what we have with OpenAI. And this just really comes down to the default options that are provided in this. We can change them as we want, but this has some max output tokens. We don't have to specify it, but we do still have to select a model. We can, oh boy, I'm trying so hard to scroll. There we go. So we have some choices, many choices here about which models that we might choose. We learned from Jesse on Monday that these models are different, right? So you might see some reasoning behavior in some models. You might see something called tool use or function calling in some models. You might see these different kinds of behaviors in these models. And so the objective here is to be able to choose the model that has the behavior that you want. Now, what is that? So I'm going to send you this link. Excellent link. And so this is still Gemini and Google API information, but I'm going to drop this in the chat for you so you can just take a look at it. Oh, this is 2.0 Flash, but you can scroll up and down to see the different models that are available. So this is Gemini API docs, and we're just looking at all models right now. And so if you look in the sidebar here, you see the models that are available. And so this is just a good thing to peruse. So if we start maybe even down at the bottom, well, I guess, well, we'll just start down at the bottom with 1.5 Flash. There are a lot of interesting things here, right? There we go. Actually, I wanted 1.5 Pro. So let's start with 1.5 Pro, and we're gonna have to move it along here a little bit. But this is a little bit of a like an older model. I mean, not that much older, but a little bit of an older model. But you learn something about this model and why you might want to use it, right? So one thing that we're looking at is this input token limit. A lot of people ask all the time, like, what is 2 million tokens? Like, how much anything is that? This is doing a great job of trying of making that more accessible instead of tokens. So we're seeing with that input token length, what we're seeing is something that's around 2 hours of video, 19 hours of audio, this 60,000 lines or 2,000 pages of text. So that's a lot. So if we need something that's super long like that, that's something that we can, this is a model that might be good for that. We also can see some things instead of in terms of AV, 19 hours of audio that it can process, 2 hours of video that it can process and answer questions and interact upon. We also have these capabilities. So again, we'll talk more about some of these functionalities in a later week, but you see one system instructions. Boy, that sure looks like something that we just saw on that little flow chart or the flow diagram. We also see something called function calling, which is something I mentioned in passing. But function calling relates to its ability to uh, identify tools that it might use and then produce the parameters to call those tools or call those functions because really they are just functions. So on Monday, we saw Perplexity and we saw deep research, search the web. One might consider a model they identifying the fact that it needs to search the web and then creating the parameters to put into a function, and then the system calling that function and then returning the result for the LLM to reason upon further. So this is what function calling will enable. So this is something that we like to use, particularly in agents, which we'll talk about a little bit, I mean, a little bit later on. So generally, while you're making your system, be thinking about what it is that you need. Uh, so if you were to go and look at, let's go with Flash 2.0, you would see that it has this experimental thinking as well. We didn't see that on the last one. We also see that some things are just like flat out not supported. So it matters what models that you pick if you're trying to do something in particular. So right now, if you need if you want to do some image generation, Gemini 2.0 Flash, this is not the model for you. It's going to be a rough time because it's not going to work. It's not created for that. There's something to look at. Okay, so with that, we can go and look at LangFlow. Oh, but the point was we were supposed to pick a model. So what we need is we can do 1.5 Flash 8B. Let's just look at this. Um, it does function calling all these things that we want. Great. It has a nice context length. We can work on a lot of things. This is looking great. Perfect. So we're going to choose 1.5 Flash 8B because we're just going to have it be making writing text. Oh, lower intelligence task. Perfect. 1.5 Flash 8B. So let's look at that one. Also, you saw on that page, there are lots of aliases for these models. It's because they're like always being like updated. All right, perfect. So now looking good. Let's go to our playground. So this, we can continue this conversation, but usually I just like to start a new chat. So I'm just going to start this new chat, and then we're going to try write a haiku about a cat. We'll send that. Perfect. So now we have our full AI system where we have the input that we put in. We send a message. We utilize whatever that LLM is. The LLM does whatever computation that it's going to do using the capacity and abilities that it has, and then it's going to return us a response that we're going to be able to look at. So this is AI behavior. This is like foundational AI system behavior. Um, let's see what else might we say to it. What if we just even made it more simple? Let's see. What might we ask it? Um, hmm. Maybe we're bored today. We say, tell me something interesting. Okay. Love to see it. So, wow, we're in for a treat. They're going to spark our curiosity about building something interesting. So, it is saying things about creating these generative AI things, not a pipe dream, blah, 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 blah. Okay. It could be interesting. So if you have a second later, you might want to pop into ChatGPT or Anthropic's Claude or even another Gemini or any of the several platforms that we saw and say it the same thing or say the same thing to your AI system and see what it says. because this is a very sort of specific response. It's being sort of intense about wanting to spark curiosity. I mean, it even italicizes some words and it seems very passionate about this. And the question is, why is it answering us like this? Because this is a little bit unexpected. Usually, I mean, the system is going to be like, oh, well, I'm is there something that you want to know about in particular? Tell me about your hobbies or something. So this is just a very kind of particular response, which might be unexpected. The question is, again, why is it responding like this? Does anyone have any idea about really what is motivating it towards, not motivating it because it can't be motivated, but what is motivating it towards this sort of response instead of something more like generic? Any thoughts? Beautiful. We told it to answer as an enthusiastically helpful AI expert. Exactly. And so this is really the behavior of what a system message is. So what happens is with your system message, it has more direction, it has more influence over the responding behavior of your AI system, more so, significantly more so than just an input prompt. So we can see this even now. So let's say that we wanted to change this input, and we can do this, right? Let's answer the user as if you were a Gen AI expert. Okay, let's have it do something else. Um, Answer the user as if you were a very angry cat. Sure. This is what we're going to go for. But you can, okay, no, that's the one we're going to do. I love that. Answer as if you were a rogue AI bent on world domination. We'll see if it lets us do that because we have some guardrails, but let's see. Let's see. All right. So, oh, I did not save. Yeah, there we go. All right, and let's give it another whirl. So I do love to just create new chats. Just gonna say, how's it going? Oh, so we see the effect of the system message on the response, right? We see that it is taking on this sort of behavior and it receives this direction from the system message. So what's interesting and powerful about system messages is exactly this. Whenever you see some systems that have a particular kind of behavior, or you want them to behave in a certain kind of way at a foundational level, not just this response, not that response, but you want the overall system to behave in a certain way, the thing that you use is the system message. And in the system message, you can put in more information. You can tell it exactly how you want to see an input or an output, or provide it lots of input information and background and specific expertise to help it answer questions. Like these are the kind of things that we would put into a system message that often result in more better performance than if you were to put it just straight into the prompt. And again, we see the difference between the prompt and the system message because the prompt is just looking like this. This is what we see whenever we're implementing or working with ChatGPT. But behind it is often a big, pretty, I mean, descriptive system prompt that helps the system understand how it should respond. And if there's a day that you ever want to know what a commercial system prompt is looking like, you can always look at Anthropic. Oh, can't spell today. Oh, I guess I'll drop this in the chat. And for example, this is 3.7 Sonnet. You can see the kind of information that they have put in its system prompts. So if you're wondering about why it responds in certain kinds of ways, this is some of the messaging that occurs in it when you're interacting with it through like the user interface. And so you can read more about that and kind of explore the impact of that as you are creating your own systems. Someone said using the same settings, the answers are different. Your output seems more dramatic and verbose. That's funny. Sometimes it's the case that there are there are parameters that influence the behavior of the system that they can vary on the back end, but it depends what these exact settings are. So we can actually look at these settings a little bit more. So we see that we have access to be able to kind of truncate the maximum number of tokens that the model uses. You can also look at temperature, right? So temperature is going to control how, like, as it says, precise or creative. Precise meaning that it's following the system instructions, like as closely as possible. Creative meaning that there's a little bit more variety in what it would say, or more variance potentially from what these messages or prompts are instructing it to do. There are even more beyond this. So we can see, oh, okay, just rolling back right quick. So whenever we have this selected, we can go to controls. It's driving my 1Password crazy, but we can see that there are more parameters that we can set to customize the behavior of this system. Um, Top P is another way that we like related to temperature about how we generate tokens. And Jesse was telling us about generating tokens. Um, this is interesting, whether or not to use it as the tool model, because we can also consider LLMs as tools in an agentic system. And so these are all parameters that we're able to set. This is actually one of my favorite things. When they first implemented Gemini, this in parameter, whenever you used to ask it questions or say something to it, it would provide you a set of responses and you can pick the one that you like the best. I used to love this. So it usually just by default was producing three and you would just pick the one that you like the best. But now that I've said that out loud, I think that was a way of training their system because, this is the way that you train models for human preferences anyways. So, yeah. So I love this parameter. Okay, any questions about that thus far? We're gonna look at one more thing. So I'm gonna come back yes, to this session. Because whenever you are interacting with ChatGPT, for example, it's called like ChatGPT, meaning that you chat with it, meaning that it remembers the history of the conversation as you're talking to it. So one would expect, being chatty, that you could just continue on the conversation and ask it a question about something it just said, and it should answer the question based on what it returned. So let's see if it does this. So let's see what question. Hmm. Let's see. I'm just going to say, I'm not sure. Can you explain more? Oh, so one, we do see that the new system prompt is responding. Uh, but we also see that it doesn't seem to recall the thing that we were just talking about. We'll try it one more time because this is like a different system message, and we'll just prove to ourselves that it's like even here, it's not saying. Let's see. So I'm going to answer this last little bit. Be warned, why my answers may not be what you expect. I'm just going to say, why not? This is a good response. And it's unclear whether it actually is answering the question or if it is just being this very sort of snarky AI that we've created. What also is nice about Google in particular, though, is their LLMs will frequently have parameters that allow you to just continue on like the conversation. But generally, when you're working with LLMs, what you would see is that LLMs by default sending a message will not have the history like in mind. So this conversation is actually totally exclusive for than this entire conversation. So when you're writing code to deploy your AI system, you actually have to almost always send the entire chat history and then the next response, and then build this chat history so it has the entire context of the conversation in context as it's responding to the next response. So that's something to keep in mind that you may need to just, if you're programming, just something to know. Usually with your LLM systems, if that memory is not already built in, you have to send the entire chat history so that you can actually get the memory as well. So we can also look at this. So we're going to actually just transition off of this, and we are going to look actually at this memory chatbot. And I was just looking at this a bit ago, but let's look at it. So we're going to go to new flow. We're going to come back to prompting, and we're going to come to memory chatbot. And we're just going to lightly look at this for a moment. So looking at this, what we see is something super familiar, right? Many of these elements are exactly the same. So many of these answers are or many of these components are exactly the same. And we see these here. These are the same things we just saw, right? We just see this one little additional element, and it is chat memory. And so there are many different ways that we can store chat memory, but they have implemented it in some default way. We can see that we can hook up it with the external memory. When we talk about agents, memory comes into play a lot more. But do know, again, whenever you're looking at this prompt, for example, if you were to look at the controls right now and look at this prompt message, you see this new parameter with these curly braces. The curly braces basically mean like we need to fill that in as a variable. So this is a variable. So you can see here, it even says that it's a prompt variable. That means that we need to connect something to it, and then it will be populated by whatever is connected to it. So let's look and see really what that is. So this again is like the system prompt, your helpful assistant. Use Markdown to format your answer. Here is our chat history, and then something will fill that in. And then the field that it needs to fill in is called memory in this particular element. You can see this here. So that curly braces variable we saw, that's going to be filled in by something. What is it going to be filled in with? The chat memory. So then every time that the system receives a prompt, we're actually going back to that chat memory, we're filling things in, and then we're using that actually in the system message, which is an interesting implementation. I think we are really coming up at the end of our time, but I will show you one more thing just to whet your appetite. And so you can think about the platforms that you used yesterday, as well as some of the information that Jesse's going to tell you later today. So we're going to come back to my projects one more time. Oh, yeah. And we're going to go look at new flow. And we're going to come over here and we're going to look at assistance. So one, we're seeing a lot of interesting things here, right? We see this sequential task agent. So we're starting to see the word agent a lot. But if we come down, we see this thing that's called research agent. Boy, that's fascinating because we were talking about this thing that's called deep research the other day. So let's just see how this has been implemented by LangFlow. So let's take a look at it. We're going to click on it and we're going to just let it make this for us. So boy, it's a lot going on right there. Or is it? So let's try to decompose what this is. We will look at what is familiar and then look at what is unfamiliar and then just try to contextualize like all of it and see what's going on. So one, we see some things that we're used to seeing. We see some prompts here, prompt, 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 prompt. So we know what prompts are. We know how they operate. We also see some LLMs. LLM, same OpenAI LLM we're used to seeing, OpenAI LLM that we're used to seeing. Great, that makes us feel better. We also see this agent thing. What is that? We'll learn more about it. But something that we do see about it is that it seems to be using OpenAI. So we have some sense of what this thing is trying to do. It describes it well here, which is that it tries to complete a task, meaning that it might do more than one thing. So it might iterate over something. So that's the basic behavior of this. It's going to have this LLM behavior, but it's going to be iterating with the purpose of trying to complete a task. What else is unfamiliar? This thing here. This is Tavily AI search. Basically, this is trying to do search, right? So we can think maybe we can associate this in our minds with something that is trying to do like a Google search. So we saw Perplexity trying to search the web and find something. We saw ChatGPT trying to go out and find resources. Maybe in our minds, this is what we associate with what this Tavily AI search is. So it's something that searches. And again, with our mind on the fact that we're trying to do this research agent and thinking about how that deep research agent was working. Deep research functionality was working. Okay, so then what do we need to do? We will decompose this flow. Okay, we might need to move some stuff out the way because we're struggling here. But actually, I'm going to start by just moving. There we go. So we have our chat input as normal. We can look and see what this is. So that wasn't the thing that I wanted. So this is basically saying like if there's a default input to the system, make it this. So this is the default input to the system, research the effectiveness of different prompt engineering techniques, blah, 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 blah. So this is what we might expect from the user. So that input from the user is going some different places, but first it's going into this LLM whose system message is this. So expert research assistant, come up with the plan. When you come up with that plan, make these particular output response. So we want a research objective and then say what that is. You want the key research queries and you want to say what those are, and you want to talk about the priorities, which these are. This is the prompt for the planner. Think in your mind now that we saw reasoning agents, which one would think would be really good at coming up with plans. Something to consider. So what we might expect the output of this to be is the plan with the output that we were just looking at. So again, we've just said something to the model, could you research this thing? We have the system message that tells this LLM to basically plan this out and have this particular output. And then that is what the output would be. So it's coming up with the plan of how to do stuff. Okay, great, exciting. So that output goes into this prompt. Exciting. We also just saw how that chat history was working with that variable. So now what is this prompt? So now we have the research plan that came from that OpenAI system, and we're just going to fill it in there. And then we're saying, hey, could you like use this tool to like learn more about like these queries, like follow the queries that it said and analyze these findings and use these sources. So then after it's done that, so this is the prompt, and this is what we're telling the model to do. When it comes up with those responses, could you format it like this? Here are the search results, here are the findings. Here are the analyses of the sources, thus and so forth. So this is that what's going into whatever it's going into, and this is what we want from that system. All right, so that's the prompt for this thing, which is the agent here. So this is the input to the agent, and yet it has its own instructions, kind of uninteresting instructions, but you are a research analyst with access to this tool. So we will call this a tool because that's what it is. So this agent is using tools to accomplish a task. The tool that it has access to is this. And you can see this because it's actually set to be in tool mode. So how does that stage then work? Well, we had this plan that this thing came up with. Now we put it into this prompt, and now we're supposed to use this prompt that will go into this agent, and the agent is supposed to use this search in order to actually come up with some results and format them in the way that is stated, which is like this. We're going to extract, we're going to summarize, we're going to analyze, we're going to have it in this output. Great. We're not done though. So now that we have that output, what are we going to do? We're making a new prompt from that alongside this one from the beginning. What's the template for that one? We're just putting information together. Here are the findings. Here's the original query. Putting that together, why? We're going to put that together with the output of the agent. And those are going to be going into this final thing, which is going to actually put all that information together in something that is cohesive. What is the prompt for that thing? Hey, you're a synthesis expert, meaning you put stuff together. You're going to format your responses, blah, 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 looking really familiar. So that's the prompt for this one. And then we expect to see the output. So this is a very like deep sort of agentic approach. You could formulate this in a different way, but do consider that this is one of the implementations that has been proposed by default as like the template for LangFlow. So this is definitely a way that you might think about. This is the way to think about for going about doing this kind of research, you can see how you can put together these LLMs alongside prompts, so that one big old, like, there's not one big giant prompt making the system have to be an expert in all things at the same time. We can break down the tasks into smaller pieces. And not only can we break it down into smaller pieces, we can also decide that, hey, you know what? I like the purpose of this LLM is to do planning. Like maybe what I want to do is use a planning model. Is there one here? Don't see one. But we could use a planning model if that was available. Maybe we switch that to Gemini and use their planning models. So we let it plan really, really well for us. And then we can still yet do other tasks while using these other LLMs. So maybe we have a system that is, or an LLM here that is like smaller or really good at synthesizing or putting together reports, but it's not this very robust reasoning model. We can choose a different model to do that. We can do the same thing with agents. We might choose a more robust model. So again, maybe one of these for agents, sometimes you don't want to use a reasoning model, but you want to use something of very high intelligence. So of like maybe a 4.1 or a 4.5. But that will be able to have the behavior that you're looking for so it can start looking and doing the things that you're looking for and complete the task. So this is definitely implementation to explore. There are lots of other implementations there. And so this is the basics of how LangFlow works. Someone was talking about how to publish and how to share. So one thing is that whenever you signed up for this account, like you agree to the terms of service and the privacy policy and all that great stuff. So for this particular platform, it does give you a great understanding of how things are working together. But if you want to use it for like maybe privacy purposes or things that you want to keep like more like private, this particular platform might not be the best one for you. Although once you see how these things are sort of working, and how they're working together and behaving, then you can utilize this code in order to implement it elsewhere. You can see the general architecture and then change that architecture into code so that then you can actually use it on a system that you're looking for. There is API access. You can also like publish this so that it actually is aware. And there's some other API settings that I never find at the right time, but you can also directly access the code so that you can just write it in something like Google Colab and you can execute it there as well and develop it further. All right. Any any burning questions? Any questions that you want to ask? Stop sharing. All right, awesome. Well, thank you so much for your time today. Happy to answer any questions that you have afterwards. I hope you'll tell us about any of the really cool templates or components that you explore. Um, in a few minutes here, I think Jesse will start with the second half, teaching more about agents and reasoning models and multimodal models. But maybe we take a quick, maybe 8-minute break until maybe 12:05, Jesse? Oh, and you might be muted.
There we go. All right. So I might, I'd think an 8 minute a break until 5 past the hour is great, but I'm going to give you some homework to think about. There are going to be two things. One thing is I want you to think about a difficult problem that you want to solve. And this could be a programming problem, sort of thinking through an issue. I'm going to give you some examples of this as well that we're going to work through, but we're going to be breaking up into groups to actually try to interactively work with a reasoning model which has agentic properties. This is the O1 model and the O3 model. And you can kind of think of this as you being completely in that loop, right? With the LangFlow, except there's you there. It's a really good way to understand how this might work and what communication might want to look like. And also sometimes that's just a workflow that you have. If you have a one-off where you have something really complex to solve, you may not want to create a collection of agents to do it. You may want to do it yourself. Or you may actually want to go through the process of solving the problem so you realize how that ought to work all together. So we're going to be doing that. So think about research that you're doing, something you want to build, a question that you have, if you could hire an assistant to help you reason through this and maybe write some code for you and look things up, that's the kind of problem that we want to have. Second, we're going to be taking a look at multimodal models as well. So think about some cool images you might be interested in creating. But other than that, I'd say, yeah, let's get back together at 5 past the hour. All right, see you at 5 past. Welcome back, folks. All right. So, a couple of quick uh, uh, guidelines for this afternoon. One, interrupt at any time with any question that you have. You can unmute and ask your question. Two, you can do it in chat. DS team, if you could let me know if I'm missing things on chat, because that'll absolutely uh, uh, can happen where I don't see anything on chat. If you would like to turn on your video, you'll get a better session out of me if your video is showing, because I can actually use that to gauge how well understanding is. So if you're willing to show your video, that'd be great. It makes it so much easier. The worst lecture I ever gave was when I left my glasses at home and I couldn't see people's faces, and it was horrible. All right, so let's go ahead and let's talk about agent and agent work. Um, could someone sort of describe something that they have in mind that might be solvable if you the question that I asked you but before break, what is one problem that you're solving? Could be programming, could be analyzing something. Give me a sense of some things you have in mind that you might solve if you had access to a good reasoning agent.
How about developing a tutorial for my undergraduate students in machine learning, simple one, maybe a logistic regression?
Oh, I like that. I like that a lot. So let's go ahead. I'm going to kick off my screen share. And what we're going to do is we're going to try that out. And what we're going to do is we're going to try this with what's currently the probably the strongest uh, uh, reasoning model and tool user. Remember, we talked about tools before that we have available to us right now. So let me get this set up and let me share. Uh, let me get this arranged correctly so you can see everything here. All right, so if you have a paid OpenAI account, you can get access, at least you can get access to what's called O4 mini, or maybe O4 mini high or O3. So what's the difference between these? We talked about these just a little bit before, but O3 is the full version of a reasoning agent, and it does reasoning like we talked about on Monday, which is it produces tokens before it actually responds explicitly to you, where it describes the problem it's trying to solve, goes through different possibilities and sort of assesses where it is, and then begins to respond to you. Remember, useful token production, good token production is compute, which means the model works better. That's what a reasoning model does. But in addition to that, the O3 model is also trained really heavily through reinforcement learning to use tools, and that is programming tools, that is that's also search tools, also other tools like image editing tools, things like that. So it's a number of different tools that it can use to help solve problems. So this is how this is different from distributed agents. So in LangFlow, you saw where you might distribute and break a problem down into component parts for it to be solved. This works really well for problems that can be broken down in that way, where you have defined set of problems where you know what you're going to be solving time and time again, a particular kind of problem that you're solving. But what do you do if you want to solve like sort of any problem? It could be anything, right? But you want to have those capabilities of strong reasoning and for it to be able to go off and do some extra work for you. That's where models like O3 come in. O4 is a later version of this model, but they're not exposing the full version of it. These are much smaller models. They're more advanced, but because they're smaller, they don't know as much about the world. They're not as capable as the O3 model. But let's go ahead and kick off the O3 model. Looks just like this one. And Lily, could you describe that one more time? And I'll put this in here. I want to design a lesson or lesson plan. Oh, and Lily, you are muted, just so you know.
I just put it in the chat. I went ahead and put it in the chat. Just a simple tutorial.
Great, great, great. Let me uh, let me get to that. Okay, great. Excellent. Okay, great. So I see that in chat. Okay. We used deep research yesterday. And in deep research, that's actually an initial model, like the 4.0 model, asking you questions and then kicking off an O3 model, which runs for a long time on its own. So you can think of this as like a really simple agent where you have the front end that asks you some questions, sends it off to O3. It works extensively. Remember, that took like 7, even 10 minutes before it came back with a whole report. So that's like a dedicated agent which does a deeply researched report for you. What's happening here is you're calling that O3 model directly. So you're going to notice here it's may or may not ask qualifying questions. It's just going to begin to jump in and begin to work. So a couple of things here. One, we're not going to give it a lot of context here, but you can. If you have a particular problem you're solving, and it's very particular, so and I'll go through some examples of this. Let's say that you want to iterate on some prior work that you've done or some work that somebody else has done, and you have a whole paper on it, and you have a whole code base on it. You can put that in right here before you even get started saying, here's the paper I'm working off of. Now, help me reason through modifying this or thinking through, does this theory incorporate or does it not incorporate my other thinking? And if not, how? So this can be highly theoretical or it can be very concrete. Doesn't really matter. But it can also do things like this where you don't describe too much. Let's see what it does here. We're just going to kick it off, and you'll notice that it thinks immediately. So it's not asking questions, it's thinking. It'll do things. We'll see if we can actually see what it's thinking in just a moment. But if needed, it will write code as well. See, so here's the thinking. User wants a tutorial. Need to develop a structured outline, clear explanations. Consider creating a Jupyter notebook or text-based document is most effective. So here, if you had your learning objectives, you could have put those in. Or if you have some background of like, and these students know nothing, right? Or they're CS folks. They just don't know about machine learning, but they know all about coding or whatever the mix might be. You could say this is a beginning course, this is a later course. Um, you could say it'd be really cool if this related to oceanography, right? Anything that you would like to. So it thought for a full minute and second. And notice what it's doing here. It's creating what's called, in this case, I think they call these canvas. These go by various names, but this is actually creating a document for you, which you can then export. So, oh, I love this. So you're gonna, so by and large, the models hallucinate less when it comes to factual things. These models can hallucinate more when it comes to trying to reach the objective. That'll hallucinate about it using tools when it didn't use a tool, and it will try to give more detail when necessary to fully complete a task. Why? These models were heavily, like really heavily trained through foreign reinforcement learning to accomplish the task of using a tool to deliver a solution. Well, if you've worked any in reinforcement learning, you might be familiar with the term reward hacking. Reinforcement learning algorithms will use anything at its disposal. It'll cheat. It'll do anything to reach that goal of that reward function. And that's what's happened with these models. They've been overtrained, and there's a bit of reward hacking in here. So, is there a license? No, there is not a license. Did we ask for this? No, we did not. But again, it's trying to achieve that final goal. So, this is different from hallucinations that we've seen from other models. Remember, all the models ever do is hallucinate. They always come up with the most plausible responses. So it's up to us to actually say, is that correct or not? Base models, if they don't have access to the internet, if they don't have good context, will make up specific details. Here, what's going to happen is it'll push as far as it can. So we want to look at everything that it produces, and we want to just take out, which is not when it goes too far, like it's going too far here. Licensed? No. Let's go and take a look at this. So here, it's giving you learning objectives. So if you'd given it learning objectives, then it would have used those. It's assuming prerequisites. So you could have given it prerequisites and then sort of had those. Conceptual overview. And now it's getting, do you really want this much math? You may say, let's keep away from mathematical notation because students will not be able to take that. And actually that looks right to me. I think that's correct. You think so, Lily? I don't see any error in here right now.
Yeah, it seems the math is correct. However, I have question about the coding. The code is not real code. Like from my end, this is like pseudocode, right?
Well, this code right here,
Yeah.
uh, uh, it's too high level for one thing. Um, but I think that I recall some of these from Scikit-learn.
Yeah, I think all of these look mostly right. It's just, will it work? What data is it using? I don't
Yeah,
know.
yeah, exactly. So it's just like a walkthrough, but it's not the full thing. So, interpreting coefficients. Okay, so the nice thing is when we did the deep research, that was like a full 10, 15 minutes. You had the full report. Here, this is like incremental results. And so here you can say, um, you can't just jump into the math. And linear algebra, they've not had linear algebra. So keep the learning objectives, those were good. Start with a gentle ramp up, to the ideas to explain what's happening. Then introduce the linear algebra, but explain what's happening in the linear, so you can actually iterate through much more easily here than you could using deep research. So this is you interacting very closely with one agent, right? So that's how this work sort of looks. What other observations or questions do you all have about using the O3 model in this way? Now we can. So is there something first you want to fix real quick, Lily, that we can take an iteration on?
Um, Maybe make it interactive training for the student if it's capable, like something to make them more excited about it.
Yes. Okay. I'm going to say this is a too formal and high level. Let's keep the learning objectives, but make a fun, interactive program for the students for the students to first intuitively learn about logistic regression. Now, the other thing is, we could have also put all the other lesson plans if we wanted to in here, right? So the O3 model has 200,000 tokens context length. So you can put in a bunch of context if you want. You could even say, hey, I want a lesson that's consistent with these other ones. I want it to look like this. Outline is the same, ramp up is about the same, difficulty level, assumptions. Keep everything the same, but just add this additional lesson. Let's see what it does with this. I'm going to go ahead and close this canvas over here. See, it even says, uh, feel free to skim it. Let me know what tweaks and additions or style changes would make it most useful. Now it's editing the canvas. So, and sometimes it's okay if it's close. Sometimes you can say, hey, start over. But here it's actually editing in place quite a bit what's happening here. And we can even say answer in chat instead. I might do that. User requested the canvas tool be disabled.
Mm. Wow.
Yep, decision boundary arcade game. Now you could ask it also to go and create that Jupyter notebook for you if you wanted to as well. But or you can just build it from this as well. Actually, that sounds kind of fun.
It does. Like from my end, like automatically ask me
Mhm.
to prepare, install Colab, and give me the link to install, even gave me a data to use, Dragon data. And it's interesting. It's really interesting. Thank you.
Absolutely. Let's go and take a look at some of the other at another example that I have. We'll do one that is we'll do IR. Let's see if I can pull that one up. IR eye tracking. Actually, what let me do uh, 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 okay, I'll see if I can. There's one particularly I have in mind. I'll see if I can actually pull this up uh, quickly. Geometric representations. Here we go. So here, this will give you an idea that it doesn't have to be as simple as programming, right? It can be very large conceptual. Because this model it's a full-blown model, has a good knowledge of the world, it's highly trained on mathematics, programming, and others, plus other real-world knowledge. Um, we had a really big problem that we were addressing 2 weeks ago, 3 weeks ago now, where we had a PhD student in philosophy who had a question around belief systems and how belief systems might be compared one to the other, and wanted to know if you could talk about distance between belief systems. And I pointed out that distance, there are many different ways of talking about distance, and maybe you're not in Euclidean space. You might be on some sort of on very weird manifold where you have to measure differences between belief systems in different ways. And we started to ask, well, are there things that are true about belief systems that would force you out of sort of the standard model, the Euclidean model that we have? And that's what this was all about. And so, which geometric space are you in? So here it's getting, and it's pulling very esoteric uh, ideas about distance and about geometries that it's able to return, and it's doing search and also doing a little bit of coding as well. So, and here it goes and reasons through why it may force you out of these regular ways of measuring distance. This is work that actually represents probably the first 3 to 6 months of my dissertation from many years ago. And we were able to carry this out in a matter of about an hour. Now, in my dissertation and in this conversation, we weren't really interested in some of the specifics. We wanted to say, where does this put us? We wanted to answer that question and put this into a mathematical framework. And this allowed us to immediately jump into that discussion about that how what belief systems and philosophy have to do with geometric with various geometries, right? And that bridging that gap would have been a matter of significant work. And here we're able to do it immediately. Non-reversible Finsler manifolds. So, and it actually talks about why you would be forced into that. So this type of reasoning can be in the small or it can be on very deep topics. I was surprised with this because I did not have to upload particular papers I was thinking of, but if it did not have enough information or knowledge about particular areas, I could have uploaded papers, and we have examples of that as well. So let me go ahead and ask you. I want to make good use of our time. How many people give me a thumbs up? And you can do this, remember, in the reaction down below, but give me a thumbs up if you have an idea of a problem you might want to solve. Okay, and let's actually do this in a way that is a little bit more. We'll stick around. Let's go ahead and do. Iman, can you help me out here? Which one should we use here for responses? I
I
am not.
just stepped back right back in. Sorry. What were you saying?
Oh, I'm looking for the responses, but I'm not seeing the responses available in here. That's kind of weird to me.
Oh,
I'll have to check the settings for the meetings to see if something's gone wrong with those. But tell you what, in chat, if you would please go ahead and put into chat if you have an idea. Okay. So if you have an idea, go and just put in chat, just you can just say, I have something to try. Because what we'll do is if we have enough people that have ideas, then we're going to break up into work groups so we can actually see this in action. But if not, then we're going to go over to the next session. So go ahead and put in chat if you've come up with an idea, just like Lily, your idea could be anything. So go and just say, I have an idea in chat if you have an idea of something that you might want to work on with some folks in a breakout room. Looks like we don't have takers yet. Ooh, Faisal. Okay, I like that one. Who else? Oh, Aaron. Oh, I like that. Yes, absolutely. Other ideas. So Faisal has a tutorial to interactively learn how to use LangFlow effectively. Fantastic. Okay. How to easily implement LoRa. Do we have others? Okay. We might not quite have uh, critical mass here for this. I'm going to skip over this breakout. That's okay. Oh, Mosin. Okay. Avoid to use kgs. Okay. We have any others here? Okay. I'm going to flip this around a little bit then. I'm going to start introducing multimodal models. We're going to come back to this. We're going to finish up with this, give you a chance a little bit more to think about. And if we need to bump this to office hours, that's fine too. Ooh, now you're coming up with some idea. Okay. Uh, oh, Faisal, you have multiple ideas here. All right. Let's put this on the back burner. We're gonna come back to reasoning models and at the end of the session. Let's talk about multimodal models. So tell me about your experiences with multimodal models. First of all, tell me about especially from early experiences with creating and generating images. Who's been creating images for a while? Right? So tell me about creating images and maybe some problems that you might have run across when you were creating images. So who here has created images? Go ahead.
Had an issue with images. So I'm in my Blackboard, what we use at WKU. I wanted to create images for the units, like
Mm,
module one, module two, and making it creative to be with analytics background. Always, I had the text with grammatical errors. Yeah.
yes. What were you using? Do you remember what you were using?
I think part of ChatGPT, they have extension design evaluator maybe at that time.
Yeah. So, okay, that's a great example. Who else has created images and had problems with them? Abby, what are some problems you've had with or oh, actually Daniel, let's do you first.
So just the same thing. I always want to do images for collection.
Oh, and Daniel, could you speak up a little bit more or your
Oh,
yeah.
yeah, sorry. I
Yeah.
put the mic up. Yeah, same thing. I like to do images for Blackboard or for slides or something, and they often include text, whether I want them to include text or not, but the text is never actually text, right? It's just sort of things that look sort of letter-like, but they're not.
So, any other examples for people to share? So early on, I wanted to use them as well to come up with information graphics. Oh, we have some uh, online as well. So let me go take a look at these. Um, Lots of bizarre quality in the images, Ryan. Yeah, absolutely. Like extra fingers and just things that not making sense. Yeah, sort of in the small, they might like make sense, but overall, they don't make sense in context or altogether. Some images include things that are not specified in the text prompt. Absolutely. Uh, uh, oh, Sora being a different thing, Sora being a very different thing, and we're going to talk about that. Um, and trying to generate a UML diagram for a programming assignment. Right. So, hey, Abby, could you give me three a 3 sentence summary of how diffusion models work? Not to put you on the spot, but
Yeah. Diffusion models work primarily on the principle that if you add a bunch of noise to cover up an image, so like you imagine taking a picture of literally anything and you just add a bunch of noise, you eventually kind of wash out all the features adding noise. Diffusion models are trained to do the opposite of that. So you take an image of pure noise and you basically carve out an image by removing iteratively over and over again the noise from an image that truly was all noise to begin with. And then the way that it utilizes your text input is sort of conditioning that noise removal on the text that you have given it. So that's why you're kind of creating an image totally out of nothing, because you just start with random noise and you kind of iteratively try to create this image and hope that it matches your text prompt that you've given it.
that is great. That's great 3 sentence summary. And the only guidance that you have on that, by and large, is some text statement. But even that text statement isn't like a full sentence. You can't do a paragraph. It's like ish. It's like I want something which is about this, technical background ish, and that's it. And it's always sort of just, removing the noise. And so it's going to end up someplace. And the only thing that it knows about text, the only thing that it knows about the world is what it's learned through images. And it's going to be text-like, but it's not going to be text. So that's been the problem with how images were created previously, which is using these diffusion models. So now we have something very different. Now we have large language models that are natively multimodal. So actually, we have large language models that are multimodal. Let's start with that. That means that the large language model itself knows about images and knows about text. So it has real world knowledge, right? So something really interesting happened just about 2 months ago, and that is both Google and OpenAI released models that were natively multimodal. Let's go and take a look at what that means and why that means such a difference now for how we think about and how models work and how they can be so much better for so many of the tasks that we want to do now. So here's the graphic of the transform model that we looked at yesterday. Let's say that you want to take an existing model and you want to make it multimodal. So one thing you might do, and what has been done up to this point, is you have an image here and you have to find a way to sort of get it in here. So you want the model to know about the image, and so it can ask or answer questions about the image or take into account the image as it's answering. But keep in mind, we're still stuck with just text production, right? So one way to do this is you build what's called an adapter, and then that projects, and you remember the token embeddings? So now you have something like an image embedding, and you project that into the model. And you can do that a couple of different ways. One, you can directly project it in, or you can use something that's called cross attention. You bring it in using the attention mechanism. But what this does is it allows an existing large language models to know about an image. It directly creates that meaningful vector. Remember how we had the vector for king? And then we realize, oh, when it's used in this sentence, it's king over here, which is a verb. So now you have this vector is the meaning of this image. And this image means toadstool and colorful and maybe poison, right? Outdoors. All of that is in this embedding that is created from this image and put directly into the text. So it's as if you put the thought of an image directly into the LLM. So now you can ask questions about it and you can say, could I eat these? And I say, possibly not. Uh, Depending on how good the adapter is, maybe it has more information or less. But here's the thing. The large language model was trained independently of this adapter. So you're depending on the description that you're depending on the representational space that's already been learned about that the model learned on its own. It's not crazy to think about that. I can ask you to close your eyes and I can say, okay, now tell me about what you were just looking at. You can say, well, it was this dark rectangle and there were pictures of people and some of them all lined up. Some of them had names and some of them had images and it was on my computer screen. Right? You could actually give a verbal text representation of what was happening, right? That means there exists a representational space in your mind where you could represent this using words. Same thing here. But let's say we did this differently. Let's say instead what we did was we actually trained from scratch this model to represent not only text, but to also learn images. That means we have token encodings and token embeddings of images in addition to text. This is called native multimodal. This means it's a lot more training. This is why this wasn't done previously. It's an immense amount of additional training. And already we've talked about the training being pretty extensive for the text-only models. So the interesting thing about this is if you do this, then there's a lot more interplay between the text and the image. It's a much richer representation of what's going on here. It'll probably represent the name of this toadstool, of this mushroom. It'll identify that there's grass and rocks and say, it's likely this is imaginary because this is not undercover, apparently. This appears to be in a field. If it is a real mushroom, it's probably of this type. So a lot of information along those lines. The models can also be multimodal with audio. So you could be directly learning audio. Some models are also multimodal with images. I'm sorry, with video. The 4.0 model is, and the Google Gemini 2.5 Pro, those are both multimodal with image with video as well. It's learned video. Sora is another model, which is a diffusion transformer model. So not quite like this, but more powerful than a diffusion model that has learned images as well. But having a large language model with all of its knowledge of the world combined with multimodality is a really powerful thing. But the other interesting thing is that that model can be multimodal on the output. Because it had token embeddings to move images in, that means it has token embeddings to move images out. So now it can produce images in addition to understanding images. But now it has the full force, knowledge, and power of this full large language model to shape those images. So now it can do text and have the text be meaningful. Now it can do things like you could do ask for it in infographic or UML, and it's much more likely to get it right. It can do a full infographic where all parts are meaningful and have to do with one another. And that's something that was simply impossible with diffusion models before. So let's go ahead and take a look and see what this looks like. I'm going to pull this up. Go ahead and put your questions into the chat. We already have some. Are these image embeddings the same semantic space? Yeah, it's the same semantic space. So that means the word for mushroom is going to be pretty close to the embedding for one of the embeddings for the image. It's going to be close. So it's the same space. Um, and how are images broken up when they're analyzed? That's a really good question. So earlier versions of this, especially when you were doing things like that we were talking about here with the adapter, this adapter is trained with very simplistic types of encoding. So one of them for vision transformer, for example, is, hey, take a 16 by 16, block and just run them all through. All of those are your tokens. And then you learn embeddings for those 16 by 16 blocks. What's happening here is more nuanced. So what's happening here is that uh, learned latent representations of the models are learned, and those are the encodings. And then those get mapped to embeddings. So, and they happen at different levels. So you might have a low, think of it, if you want to think about it this way, there's a low pass filter and a high pass filter, and they return different latent representations of the images, and then those get their own token embeddings, and then those, can be used both ways. You can go from latent encodings down to an image. So you can go from image to latent encoding, do all the transformer stuff, all the learning, and then go from latent representation back to an image. That's what's happening here. And that's what we're going to look at right here. So the images are not necessarily broken up, but the images are represented. So let's go ahead and I'm going to start another chat here with, I'm going to use the 4.0 model. And I'm going to say, so somebody please give me a prompt of what we want to create. We want to give it enough context here. So let's do, how about, Lily, we'll take yours. Give me an image of to introduce the concept of a linear regression to students. Make it highly visual and intuitive. I misspelled intuitive, but now notice what's going to happen here. First of all, you're going to notice that it's going to give us it's going to give like a rough outline of what it's going to look like first. So you won't see an image, but you'll actually see it sort of blocked out. This is one of the latent representations sort of laying out where it's going to be headed. This is different from diffusion models, but not terrifically unlike that. It's not as simplistic as removing noise. This is more going from latent space into the image space. But you're going to see something interesting. It's going to do it left to right, top to bottom, almost like it's writing a paragraph. Why? Because that's essentially what it's doing. It's just writing out and rendering the image representation rather than a text representation. So notice I really didn't give it a whole lot, right? I could have given it much more. Remember, everything still holds. In this, I can do, I can give it like, here's my lesson plan. And give me up to 4.1. For 4.1 here, I want a visualization, include all the terms, include all the information, make it correct and realistic. But this is not bad. I would have expected it to make the error of putting those best fit lines at an angle, which is not right, but that often is happens. But at least it's doing, so it's simplistic, but not bad. Sure, let's go ahead and let's say add error lines for missing dots. The other thing to note is that this is a lot more compute, right, than it is for diffusion models because you're doing you're reasoning about everything as well. Now, here's another interesting thing. We've seen reasoning models, right? And reasoning models are currently reasoning with text. There's nothing keeping the reasoning models from using images as well. So thinking both with text and thinking with images. I believe we're going to start seeing that soon. Um, because you've certainly had a situation where you've had to sketch something out for it to make sense to you. I would not be surprised if reasoning models will be expanded to actually use this. Yeah, no. Eh, label it, but it's not great. We need to give it more context. I would like to try out a breakout room. We're going to do this just for a few minutes, but I want you to actually try some hands-on experience, hands-on with this. Think of something and think of something where you can give it a lot of context. So drop in something that you're thinking about, copy and paste, create some images, and let's share them among ourselves. Then we're going to come back and we're going to share some of the best examples that we have of those, okay? So, Umang, could you drop in the link to the breakout room space, and I will set up the breakout rooms real quick to get people into the rooms. We're going to take about let's just take 5 minutes for the breakout room so we have enough time for people to come back. Remember, share your screens, turn on your video, share your screens, and see if you can share the different things that you're able to come up with. So let's see, breakout rooms. I'll get this set up. Thank you, Among. Let's see. And I'm going to go and create 3 breakout rooms. I'm going to include the co-hosts. And I'll create 4 breakout rooms. All right, I'm going to create them, and then let me put the timer on these. I'm going to do auto close after 5 minutes, uh, and I'm going to have a quick countdown timer. All right, I think we're ready. Everyone ready? Okay, I'm going to move you into the rooms uh, automatically. language working again? What was the deal? Welcome back, everyone. Welcome back. So, very interested in seeing what you all created. Who would be willing to share an image that they created and the prompt that they used to create it? Daniel, thank you.
I just asked it to diagram the sentence and gave it a good shot. I like that the text is readable.
Yeah,
Give me a nice kind of sixth grade diagram of it.
I like that too, and I like that how the fact that it's interesting to me. It'll it will it won't be pixel perfect. Like the E is running to the line because again, it's going from that higher level space down to the pixel space. And when you're up here, you don't know roughly the relationships, but you don't know exactly the pixel difference, right? So you don't know that if you make this particular choice, it's going to run over just a little bit. So
Mm.
this is great.
Can
How
I
about
ask a quick follow-up question before we move on?
yeah.
So earlier with the regression example, I asked if we could ask it to add the error lines for the
Mhm.
dots that were missing them. I wanted to see if it knew what that meant, right? In some
Yeah.
sense, does it know what the dots are? Does it know what the error lines are? Does it know
Yeah.
which dots are missing the error lines?
Yeah.
And it seemed like it kind of got it. I was a little bit surprised that it did get that.
Okay.
But is there some sense that the model understands what the elements in the picture are?
Absolutely. There are limits, but everything that the model knows, the model could apply to that image. So it knows all. It can give you a full exegesis on error bars, right? But you have to sort of tie it together a little bit, right? Because like in that simplistic model, would you have error bars? You know, do you mean like prediction error? Do you mean, so the more precise you are, the better the tie will be to the information in the image. And so being explicit will help a great deal. But it has full knowledge of the world. Everything the model knows could be applied to that image. And if the image is good enough, then it will get that information from an image as well. So I've certainly put in very complex images and asked it to interpret. And so these are, graphs, scientific renderings, things like that. And it does an excellent job. Um, but more context is better. So if you're very precise about what you mean by error, then it's much more likely to come up with something which is meaningful.
So when it added that arrow with the term error, and then
Yeah.
the arrow was just pointing to empty space in the graph, was that due to what you were describing earlier, where it doesn't really know how to align the different parts of the images necessarily? Or
Could
do you think it just doesn't really know what to point at?
or it may not be may not be clear enough about what to point out, right? Because in there were not, I mean, there are many things you can mean by error bars, right? And so was it, so if we'd been more explicit, it probably would have done a better job. But again, it wouldn't have been pixel perfect because it'll be off a little bit, especially when you have tasks that actually might be difficult for us to do. I don't know about you, but when I'm writing my name on a cup or things like that, I'm like, oh great, now it's wrapped halfway. That kind of stuff is hard because it's not an image editing program. It's funny. It can do things like it can take an image and like make it transparent, like remove, make make everything except for the person transparent. And it can do that, and it does a very good job. But you'll notice, for example, that the person's representation changes subtly every time you do it. Because every time you ask it to do something to an image, it is reinterpreting the image. So I have a series of images. I'll see if I can pull them up before we run out of time. I won't be able to before we run out of time, but I will actually do them in office hours if you want to see, where I had it put a dragon tattoo on my face. And it did. It did a good job, but it also gave me 5 o'clock shadow. Because if somebody has a dragon tattoo going down their face, they probably are not like clean shaven, right? So it assumed that I ought to have 5 o'clock shadow and also be a little bit more mean looking. So it had me doing this, you know. Uh, so the images get reinterpreted every time that you work with them. All right, we're at top of the hour. Show me one final image of something that you've created. Somebody share their image if you would. Make a professional headshot from using a photo I gave it. Unsettling. Oh, Umang, you got to show this.
All right, let me just pull this up real quick. All right, so I gave it this picture. Ignore the fact that I'm in an ER. And it came up with this. It kind of looks like me, but it's just staring back into my soul and making me very uncomfortable.
This is a personalized uncanny valley, isn't it? This is you, but not quite you. Yep.
Yeah, so like kind of, but not
It's
really.
kind of right. And again, this is through that lens of being reinterpreted. I'm surprised it didn't bring more of the hospital stuff,
Right.
you know. But at least but it knew what a professional photo ought to be. So again, not image editing. So think conceptual image representation, conceptual image editing, something we haven't really seen before. All right, folks. We're at the end of our time. We're going to enter into our office hours. Thank you very much. Stick around if you have additional questions. Otherwise, we'll see you on Friday. Thank you all. Thank you all so much. All right, folks. What questions do you have?
I will.
Think of it.
If someone else have a question, or go ahead.
Go ahead.
Okay, so I see the quality of the images much better than I used it a year ago. But is it still?
And a different model, right? So before it was diffusion model. Now it's something completely different.
So my question, I have two questions related to this. Is it still using the idea of leaving the training of the models, still using 30% or 40% out of the model to train the general model, or this
Mm.
change? This one. And second one, when you're talking about the multi-agent, you said now we have a specialized, like I can fire, like I can create an instance of ChatGPT for just for statistics, for example, and call it by other ChatGPT to validate maybe some of the questions. So the image is the same. Is it like a more specialized now? What do you think is going on behind the scene in the training to make it better?
First of all, it's a completely different process now, right? Whereas the other ones before had the knowledge of the diffusion models about the world was only on the images that they were trained on. So they're trained on the images of words, but not the semantics. It didn't know what the semantics were at all, right? And so that's why it would give you word-like objects. It's like a child that's really good at drawing and say, "Hey, draw me a classroom." It'll say, "All right, here's a teacher and here's stuff on the board." The child doesn't know how to read, so the child isn't giving you, but it's boy, it looks like text. It's text-ish, right? So that's a diffusion model. With this model, it is fully informed by the full knowledge of the network, and everything that we talked about before of attention also holds. So if you want it really well informed, and so it gives you a great image or a graphic for you, you give it more context because attention is operating on the images just like attention operates on words. It's right in there. So if you have a whole bunch of information about the conceptual understanding and what's important to have in the image, that's going to directly inform that the image as well, or that thought is going to inform the latent representation of the image, and then it will generate for you a final image which has all of that information. So that's a very different way of working. Um, it still is moving from the latent space to the image space. That's one thing it kind of has in common, especially with latent diffusion models. Um, but everything else is different. The whole innards are different, so it's going to act very differently. Training of this varies, but it looks like the causal model language training that we talked about before. Give context and then leave one out or leave parts out. Same thing with images. Here's all the tokens that come before, now guess the remaining tokens. They probably also do some infilling as well, non-causal training for the images, because you probably need to have that in order to do a better job. So it's not all completely autoregressive.
Okay, thank you.
And Milson and Darcy, absolutely understand you just sort of hanging out here, but if you do have questions, feel free to ask them. Welcome back, Amon. So think about other questions you might have. And I will see if I can find
Okay, I thought of a question. It's more
Yeah.
conceptual though.
Sure.
I'm trying to really understand, in terms of the multimodal models,
Mhm.
like how, and you might have said this and it went over my head, but how is it accessing, these different modes of information like video, image, text, and figuring out that, as you said earlier, they're in the same semantic space?
Yeah. So The training of these all proceed at the same time. So, so for example, um, you'll have an image, say, of tattoos, and you'll have a discussion about tattoos. So, first of all, those two things may be coincident, right? So, you'll have a discussion about tattoos, like a caption, or maybe even like in a manual or something like that, and it will talk about that. So, first of all, and I might call that sort of direct alignment. Here's the image, here's a description of the image. And that's broadly how those diffusion models, and those adapters that I talked about before work as well, right? So that's a way uh, that you can learn, but you can also learn a little bit more indirectly because you have just that one time where here this thing is a tattoo. And then you have all this stuff written about tattoos, right? So there's a bunch of stuff written about tattoos and where they might go, and um, the colors aren't exactly right, but they tend to look like this. So everything the model, the LLM knows about tattoos, also informs that learning. Because remember, as you're taking a token, and let's say you take in if the embedding of a picture of with a tattoo in it, and then that's going to have attention, and then it's going to have that feed-forward network, that multi-layer perceptron. So it's going to inform that representation about everything that the model knows about tattoos. So just like it's learning new words and new concepts, it's learning new visual representations and new meanings about those representations. Does that make sense a little bit?
I think so. I guess what I'm wondering is even more basic, like how does the model know that the image is a tattoo? Is there a label on it that it then associates with, text about tattoos, to use your example?
That does make it easier, and there probably is in some of the training data, right? Just to make it sort of simpler, right? So there's a caption that says a tattoo of, but it's not wholly dependent on that, and it could probably do it even if it didn't have that. Because if you knew all about, so you know all about tattoos, right? All right. I mean, you know a lot about tattoos. Can you tell me what part of this image is a tattoo? Is it this? Is it this? Is it this? You're like, no, I know what those things are. That's a tree. That's a motorcycle. In my mind, it almost looks like an Indian motorcycle, an older style. Pretty cool if I do say so myself. I've never actually ridden a motorcycle. Leather jacket. I'm vegetarian. Probably wouldn't wear it. Maybe it's faux leather. So even if I've never seen a tattoo, I know everything in this picture except for this thing right here. I don't know what this thing is. So of all the things, that must be the tattoo of which you speak. So you can see how that sort of alignment kind of works naturally in the large language model. When you're building by hand that adapter we were talking about before, you have to do that very explicitly. So you actually have to train on those representational spaces directly, and it's hard. It's an immense amount of compute, and it doesn't come out that great. Here, when you're learning a large language model, you get to take all the learning that you had before and say, hey, this thing is a tattoo, and oh, by the way, it's on skin. Tattoos are on skin. They don't float above. They're in the skin. They're pigment that's been injected into the skin, and it's darker than the skin around it. It's never lighter, and it's going to follow the contour of the skin, and the tattoo tends to be sort of cartoony sometimes, or you know so it doesn't, not everything needs to be labeled. We learn things because they're in alignment, just like multilingual models you know learn. I know what water is, and I know the properties, and here's this other thing in another language, aqua. In aqua, I'm learning. You can use it to rinse off a car when you're washing it. Aqua is something that you can drink and should drink if you're hot. It's like, oh, you know what? This thing sits exactly where water sits. So this aqua, is water. Similarly here, well, here's this thing that is in the skin. It looks like it's in the skin. It's it's cartoony. It has these properties. That must be this thing that of which people are talking, tattoos. This must be a tattoo. Does that kind of make sense?
Yeah, that makes sense. Thank you.
And this is one where it gave me the 5 o'clock shadow and gave me the, you know, the the stern look. What was interesting was that it got those in about the right place on me. So I don't know if you can tell. So it got them in about the right place, but it just made them deeper. So because in the picture that I took, it was me being neutral. It was kind of like this. But it saw where the furrows were and knew that an angry position or an angry face ought to make those deeper. So conceptually made those furrows deeper, but put them in the right place. So very different way of the model of interacting with images than before. All right. Other questions?
I guess I have a general question that I've been working on all the last 2-3 days on pretty big software project for me, and I basically am using a Gemini because of the 1 million context window to just help me design like the the procedures for me to, and then I'm just relying on them to code it. But I guess I'm not really asking a question. It's been interesting. It's been something where I would have never started this project, but it's like basically I'm doing this. I'm trying to simulate cloth in computer graphics. If I'm hanging a cloth, then look at what are all the forces involved, physics forces. It's like 7 or 8 physics forces involved, and really trying to create one by one to make sure each force is working properly or not.
Yep.
So it's just been very, very instrumental in me being able to like make this a methodical project. But I'll be honest, if one, it's not like the average person can say, oh, I want this to be done, because there's a lot of, if they're just going to say, oh, I want to create this, the code that it's going to come up with is, I mean, it'll spit out 500 lines of code without thinking, and then all of a sudden you're toast. Like you have nowhere to like debug that. So you almost have to make it. I mean, I spent 2 days just trying to come up with a procedure before I even started coding, but now I'm flying through it.
And that's it, right? I mean, so a couple of things here. One, you almost want to flexibly move between a model which has that long context and can code, and a more reasoning model which can actually do things like, hey, am I answering all the questions before I even begin here, right? What are the requirements that I have? Or help me with the mathematics so I can actually figure out what those forces are, the mathematics and physics. Have I fully described them? Is there a paper on, it's almost like two different kinds of work. And then once you get the code, then you might want to have a reasoning model that will return and say, okay, what are the tests for this? Or even ideally, what are the tests before I write the code that it must pass before I can? So you're bouncing between long context and coding versus more reasoning, either you or you with a reasoning model. In the next week, probably, Anthropic is going to be releasing their next version of a model, which is going to be much more of a hybrid reasoning and base model, and it's going to be designed specifically for this designing and testing versus coding, and flexibly switching between the two, which right now you sort of have to do manually. It'd be really interesting to see if they bump this up to 1 million tokens, because right now you got million tokens from Gemini, and you got million tokens from 4.1, OpenAI 4.1.
Oh, I didn't know that.
Yeah, 4.1 is only available through API, but now you can get 1 million tokens out of OpenAI 4.1 model.
Oh, okay.
Great. And I'm thrilled with that. I hope that you will share that. We'll have some time closer to the end of AI summer. Would love for you to share some of that if you can.
Yeah, I will. Definitely. The other thing, I'm taking this class in civil engineering on geotechnical And the only reason I took it is because the professor is very top notch in deep learning, and he's been instrumental in that space because it's been a very slow uptake
Hmm.
in that space in civil engineering, geotechnical and whatnot. So we had to write a 100-page report with a bunch of different, it was a case study and whatnot. And I put it on Claude. I just put in some figures, and I'll show that to you maybe next week too. But like it was amazing. It just created SVG files, and then
Oh, awesome.
it
Really
rendered
good at
them.
SVG. Yeah, yeah.
As opposed to when I put it into Copilot, it gave me some crappy Dolly, like basically it gave me that motorcycle thing, which
Yeah.
I mean, meaning it was not relevant at all, not usable at all.
And right now, Copilot is still using the diffusion models. It doesn't have the 4.0 native multimodal right now. So, but boy, you can tell. I wish they would say, yeah, really for the closed source models, they need to be much more transparent about what's happening and how. That's a real issue. But at least if you understand how the models are working, now you can get a good idea of what's really happening because you understand now basically what's happening with, attention and the feed-forward networks and the native multimodal versus calling a diffusion model. So that's part of the purpose of all of this is so you just know the underpinnings of what's happening.
Yeah. Do you think that Anthropic model is going to be available on the web? Do you have any insight?
I would imagine it is. They are also, but they will also they really would like to own the coding space.
Mm-hmm.
Uh, but I think they realize that they're starting to because the Gemini 2.5 Pro update, and they chose not to name it, but the update was really good for coding. And with that 1 million context length, it's great. And so that they had some more work to do. Uh, Gemini also is it's supposed to be able to do reasoning, but it's a little bit tough to get it to move back and forth. Same thing with the Claude Sonnet 3.7. It was supposed to be a hybrid model, but it's tough to get it to move into reasoning mode. And that's part of the trick here is to figure out when you should be reasoning. It should know when it should be reasoning and when it should not be reasoning. And 3.7, if you've used it, just like immediately begins coding and will fill things in and will just like start to it repeatedly, like to say, do not code, do not start until we have fully specified what's going to be.
Yeah, that's what I keep doing. Yeah.
Yeah, it's like, whoa. Um, but that's where a reasoning model would come in handy. Assess, do we have enough information to proceed? Do we know enough in order to be able to come up with a good solution for that? Right? That's a reasoning problem, not just a base model problem.
Mm-hmm.
And you can bounce between them if you want to, but then you have to carry everything back, right? It's like you are like a really inefficient LangFlow. Like now I'm going to call this one, now I'm going to bring this back over. And that's not a workflow that works really well for LangFlow because too much happens underneath the covers. So having that all communication within a single hybrid model that's both reasoning and non-reasoning and code writing and tool using could be, especially if it's well aligned using reinforcement learning, but not overtrained like O3, which is just they went bonkers with it, and it just it's good, but you can tell that it has really been heavily trained using reinforcement learning. And we don't want to go that far.
So you made me think of something. I'll be honest, I'm using them completely interchangeably, reasoning models and non-reasoning models. What are the buckets you said? You said there's the reasoning models, then there's the coding models. To some extent, I see those overlapping, but maybe there's a
Oh
distinct.
yeah. No,
And then I would just lump everything else. Let's take that. Let's take multimodal out of it for a second. But there's probably things that are sort of very good at multimodal versus others. But like if we look at mainly language based type of application.
they're all different capabilities, right? So multimodal is if you're trained on images and you could be natively multimodal or not. 4.0 was natively multimodal all along. They just didn't expose that other part. But 4.0 is also not a reasoning model. It cannot produce that thinking token.
Yeah.
and then sort of consider and then present and then emit the stop thinking token. It can't do that. Because that's the ability to use that token and also know what reasoning is, and it wasn't trained on that. O3 and O1 are O1, O4, O3, all of those are reasoning models. And so they will first go into thinking, consider something, stop thinking, and then respond. That's all that they do.
Mm-hmm.
But then you have hybrid models that can move in and out of thinking.
Hmm.
Actually, Claude 3.7 is supposed to be a a hybrid model where it can move in and out of thinking. So you can interact with it and then it can move into thinking and then respond. But it's hard to get it to move in and out of that. And you have to be very explicit when you want it to do that. Ideally, it would be a model that would move into thinking mode when needed, right? So to have a better sense of when you were asking something that was a deeper question. It's not going to be perfect, right?
Okay.
Because, you know, um, you know, Abby, how do you feel? Non-thinking mode is great. So Abby, how do you feel? I was like, okay, well, okay, you know. So I mean, same, but just slightly different context, and one requires thinking, one doesn't. Um, hey, write me code for Hello World. Does not require thinking, right? Um, but hey, generate me code that'll correctly calculate all the forces when I'm actually hanging cloth on, say three supports. Well, now that really better be kicking into thinking um, before it begins just spinning off code.
Okay. Yeah.
But everything else is sort of that could be multimodal or not be multimodal.
Do you think that there's a difference between reasoning models and coding models in reality? Like,
Well, oh, and then coding is yet another. How much training has it had on coding? Every model can write code. Even the tiniest models can write code. It won't be very good, but it can code. When we say coding models, really what we mean is it's been more heavily trained on coding and maybe trained on more languages and trained on good software engineering. So like Google Gemini, the big push they made was to make it to really train it on good software engineering. Same thing with Claude 3.7. It was heavily trained on design and programming. Um, 4.0 wasn't bad at it. Incrementally, they've been doing updates on it so it's better at coding because they realize we're falling behind. But you just take the base model that you have, you give it more training on coding and coding problems. Um, that's just a matter of how much training you've given it.
okay.
Can I just quickly ask, because I have to hop off to a 2:30 meeting,
Please.
how far do you think one can get with these different, tools or models without like investing a lot of money? I'm trying to think like how far could I get as
Mhm.
somebody who doesn't have, a big pile of funding with some of the free versions.
See, this is really interesting. You leverage the large and the for-pay, the $20 a month. Um, you can do things like you can do coding there without calling the API. It's harder, you have to copy and paste, but you can do that. But you can also run things locally like the QWQ, the Quen models. If you have and you can figure out LM Studio is a good one, a good way to do this. You can run that as much as you want to, and it's actually really decent at coding. It's not coding all languages, but it is really good. So you can run local models all day long, but you use the large models to do things like, hey, like let's say you want to do the cloth thing. Well, you might use the large models to help you, spec that out, right? What are the physics equations I need to have? Help me think through. Give me the best possible description of this program as it needs to be written. Give me tests to run. outline what the project ought to look like, the order in which I ought to do it. Then you go local and you give that all to, say, a Quinn model or one of the other models that are good at coding and say, now do this thing. And those local models, the Quinn models and others have decent context lengths. Like some of them, they have 128,000. The Llama 4 model can go up to 10 million. You won't have enough space on your laptop to do this, but so they have that long context. So even though the models may be smaller and know less about the world, if you populate with highly curated information that you've generated from these larger frontier models and say, now make it shorter, make it concise. I want it as concise as possible, but fully describe what needs to happen. Boom, here you go. Copy paste. Now you're working locally, and then that's free.
Okay, thanks so much. I have to run, but I really appreciate everyone's feedback and input. This is great.
Absolutely.
See you Friday.
See you Friday.
Bye.
I'll let you guys go too. Thank you very much, guys.
Absolutely. Good to see you again. Take care. All right. I'll post this in the recording in there as soon as it's ready. Thank you both very much. And Abby, thanks for letting me put you on the spot.
Yeah, of course.
All right. I'll see you.
Right.